Hey everyone, Anthony here. So I was doing a previous video about a shuffle, converting a new shuffle node to the older shuffle copy node. So just thought I'd do a quick PSA. So I'm currently in Nuke 13. So from Nuke 12 forwards, you have access to, there are 3 shuffle nodes. So there's shuffle copy, there's shuffle, and there's Shuffle2, right? So I'm going to ignore shuffle for now. That's less of a problem. So we'll go for shuffle copy and the new shuffle node, which is here. There you go. Right. So the new shuffle node has this fancy new interface where you can do things and move it around. It's pretty cool, actually. I like the new interface, but there is something you probably should be aware of. So let me reset this back to default. So we're going to get a shuffle node. So I am going to move this to one side and I'll show you the problem directly. So I've got the color wheel here and I'm going to just make another copy of it. Right. So I'm going to put a viewer on shuffle and shuffle. So shuffle 5 and 6. So I've got shuffle 5 and 6 looking at the color wheel, no changes. So for shuffle 6, we'll align this left, right, okay. Yeah, that'll work. All right, so on shuffle 5, what we're going to do is we're going to set everything to black so we see nothing. And we have the same thing here, so no problems yet. We're going to drive red to red. So we're only going to see the red of the color wheel, which is this section of it. Okay, that's fine. Shuffle 6, same thing. So no changes yet. So on shuffle 5, this doesn't happen very often, but we'll do this. We're going to also now drive the red channel from blue or alpha. No, let's just do blue. Okay, you'll see it change. Now this is the behavior that's sensible for the old shuffle copy node and the old shuffle node, which is there you go. So here with the shuffle copy node, if we do this, there is a very clear ordering. You do this section stuff at the top, and if there's anything down here, it wins. So that you don't get to move these around. It's the one at the bottom wins, right? So that's shuffle copy. That makes sense here. So in shuffle 6, what I'm going to do now, so shuffle 6, they are different because we're doing different operations. Red to red, blue to red, so therefore blue is red. Kind of, that wins. So on shuffle 6, we're going to do that now. Blue to red. So 1, 2, same view. We're going to do now red to red. 1, 2. Okay, so this again is logical. Red to red, blue to red, second operation down at the bottom, red is now blue, and the exact same, but the second one is always the winner. Right, so let's disconnect these. Let's now break it. So we want blue, we want to look like shuffle 5. So shuffle 6 here. So let's go red to red, blue to red, red to red, move it around. Okay. So you saw what I did with the connections. Nothing particularly exciting. I have different pixel results. So yeah, just be aware, this is a characteristic of the new shuffle. Because you have user level ability to rearrange these two boxes, you can potentially get different pixel results depending on how a user has made this mapping. Now, this should not affect many people because it's going to be quite rare you do an RGB and like you're going to do something like this where you deliberately use the same channel twice and you deliberately override it. So I don't think it's a huge problem, but it is something to be aware of because I don't think anyone expects to get 2 different images from what visually looks like 2 identical nodes. They're not actually identical. Under the hood, if we go to shuffle 5 and shuffle 6, you can actually see, we'll clean this up a little bit. You can actually see the mappings is what controls it. And you can actually see there's a difference here. So if you read left to right, 8, blah, blah, blah. Oh, wait, there's a number 1 here and there's a number 0. So there is an internal difference between these two things that makes one operate differently. So that's good. It means it'll persist around copy and paste. But if we look at this one, Nuke selected node, right, so that, if I run it again, so if we bring the result of the Python call, oops, if we look at the results of the Python call, these two are identical. So if you look at the Python call, you will not be able to distinguish this situation. You'll actually need to look at the underlying TCL that's driving the node itself. It's even, I don't know about worse, but it's even more annoying in terms of this, because this knob here, come on, this is called out1. This is also called out1. Out1 is always the topmost. So that is actually what's happening under the hood. Yeah, this is a very short one, but just for the people who are more technical or who are mucking around with this, just do be aware that if you do the situation where you are creating setups like this and people are overriding channels this way and they're changing order, it actually is important the order which they were, oh god, it is important to know what the original order at which people created these nodes, this mapping was. You can get the information by looking at the mapping knobs script value. So you can do to script. Oops, no selected node, obviously. You can get this out, but you would need to parse this yourself. I'll probably write something for this in a second. If you look at the normal values call, you will not. So yeah, that's probably just a minor PSA for any of the TDs out there who are dealing with this stuff.